Alright, this is going to be AP Calculus. This is going to be Self-Check 4.1. These are going to be the solutions. There are 4 problems for 4.1, which means give yourself 8 minutes on average, or 8 minutes, more or less, 2 minutes per problem, and let's do this problem. Number 1, C, mean value theorem. There it is. Okay, mean value theorem. Every time I see this guy, I immediately write the definition. So this is f prime of C. That will be equal to f of B minus f of A all over B minus A. Okay, moving on. We have our f function here, so let's take the derivative and then plug in C. The derivative of f of x, so f prime of x here is going to be 3x squared minus 4x, and then plugging in C, so f prime of C now is 3c squared minus 4c is equal to, okay, now we have to figure out what everything here is. F of B. Well, this is A and this is B, the start and end, which means if I'm plugging in into the normal function, just no f prime, just f of B, that's going to be plugging in 2. So plugging into f of 2, this is really f of B, this is going to be equal to 2 cubed minus 2 times 2 squared, so this is going to be equal to 8 minus, it's going to be 4 times 2 is 8, so 8 minus 8, so we get 0 there. So let's plug in 0 minus, and again on the bottom B minus A was 2 minus 0, 2 minus 0, and now we need f of A was 0, so I need to find f of 0. That is equal to, plug it in 0, I get 0 cubed minus 2 times 0 squared, and that is equal to 0 again. So we have 0 minus 0. So we really have the equation 3c squared minus 4c, 3c squared minus 4c is equal to 0. The denominator is not 0, so that worked out fine. Let's go ahead and factor and solve. So if I factor out a c here, c times 3c minus 4 is equal to 0. That means, remember, endpoints, yeah, you can't use endpoints on this one, so don't worry about the c equals 0. Well, I mean, eventually you will get c equals 0, factoring this one, and then factoring the right one, you get 3c minus 4 is equal to 0, using the 0 product property. Adding the 4 to both sides, divided by 3, you get c is equal to 4/3, and there it is, 4/3. Again, it can't be 0 because that is an endpoint, so don't worry about that one. Alright, so moving on to number 2. The radius of a circle is increasing at a certain instant, the rate of increase of the area. So rate of increase of the area, that thing means A prime. The circle is numerically equal to twice the rate of the increase of the circumference. Rate of increase of the circumference, that's C prime. So as a sentence, A prime is, so is means equal sign, A prime is numerically equal to, and it even says equal to, twice the increasing rate of the circumference, 2 times C prime. What is the radius of the circle at that instant? So what is the radius at that instant? Okay, so remember that area of a circle is equal to pi r squared, therefore A prime is equal to 2 pi r prime, and circumference of a circle is 2 pi r, therefore circumference prime is equal to 2 pi r prime. So I'm basically plugging these into the formula, and let's see what we get. We are going to get a 2 pi r prime is equal to 2 times the quantity of 2 pi r prime. Alright, and then you'll notice here that we have a 2 pi r prime, a 2 pi, and an r prime. So those will get canceled out. So we'll say that goes away, those go away, and you're left with an r is equal to 2. And there it is. D is the answer. And we don't have units here, so don't worry about that, it's just multiple choice. Okay, number 3. The radius r of a sphere is increasing. So if it's increasing here, that means it's r prime. And it already tells us per second, that's another indication that it is r prime. So we'll label this r prime is equal to, and it is increasing, so it's a positive, and it's going to be a positive 0.3. Units are inches per second. That's good to know for later. At the instant when the surface area becomes, okay, so we have surface area, capital S. This is going to become 100 pi square inches. What is the rate of increase? Rate of increase. This is, sorry, it's a rate. So it's going to be something prime of the volume. So we're looking for V prime. All right, so what do we know? We know we're going to be using V prime, so we can go ahead and set that up if we want right now. So we can say V prime using our volume equation over here and taking the derivative. The 3 gets multiplied down, the 3's cancel out, and you're just left with V prime is equal to 4 pi r squared r prime. All right, can we sub in everything that we have? We have an r prime, and we don't know what the r is, otherwise we'd be done. So we need to find the r somehow. So let's come over here and see how we can use the remaining information. We have r prime. Oh, we haven't used s, so let's use s. S is equal to 100 pi. Well, I'm not using s prime, I'm just using s. So s is equal to 4 pi r squared, just rewriting the equation, and that means 100 pi, just subbing in my 100 pi that I'm given, is equal to 4 pi r squared. Dividing both sides by 4 pi, I'm not even going to write that out, and you'll get 25 is equal to r squared. Therefore, r is equal to plus or minus 5, and you can't really have a negative radius in this problem, so r is equal to 5. And now we have r, so now we can come back to this problem and substitute that in. So we have a v prime that we're trying to solve for again, and that's going to equal to 4 pi r squared, so that's going to be 5 squared, 5 squared, and then r prime is 0.3 times 0.3. All right, well, 5 squared is 25 times 4 pi is going to be 100 pi. So right now v prime is equal to 100 pi, but I didn't multiply the 0.3 yet, 0.3. The 100 is going to move the decimal place 2 places to the right, 1, 2, and it's going to be 30. So the v prime is really going to be equal to 30 pi, and is that, it is in here, okay, cool. E is the answer. And if we were doing units, it would be inches cubed per second if it was free response, but it's just multiple choice, we get E. And last but not least, number 4. We have a right triangle problem. So ABC has its right angle at A. So let's go ahead and make our triangle. Okay, its right angle is at A. Again, you should always try to make a picture when you're doing these problems because they are a little bit harder to visualize. Leg AB, so AB is decreasing at a constant rate. I'm just going to arbitrarily, randomly say that this is going to be B, which means that this leg right here is decreasing at a rate of 3 centimeters per minute. So I'm going to call this this whole length C. I'm going to call this whole length A, and I'm going to call this whole length B. I know it's lowercase and capitals, it kind of gets mixed up, but this means C prime, because that thing is decreasing at 3 centimeters per minute. So this is going to be negative, because decreasing, negative 3 per minute. Okay, so leg AC, so this is capital C, leg AC, this guy B here, is increasing at a constant rate of 4 centimeters per minute. So this is increasing, so that means B prime is equal to 4. And, okay, 4 centimeters per minute. How is the hypotenuse BC, this hypotenuse, good, we have the picture correct, changing at the moment when AB equals 12? AB, so that means C is equal to 12. And AC, this length here, B, is equal to 5. So B equals 5. All right, so setting up our Pythagorean theorem equation, remember it's A squared plus B squared equals C squared. Taking the derivative, it's 2AA prime plus 2BB prime plus 2CC prime. And we can divide everything by 2, so we get A prime plus BB prime. Oh, made a mistake there, sorry. Is equal to, whoa, it's a giant eraser. Let's try that again. Is equal to CC prime. Okay, so plugging in what we know, we have an A, no, sorry, we don't have the A yet. Oh, whoa. I've made a mistake here because I'm setting up the variables, but that doesn't match my case over here. So if I actually rewrote this, it should have been a little bit, I'm just going to change this final line. I think everyone can follow me in this respect. But it should have been C and B. So let's switch the A's and B's here. Sorry about that. I guess I should have labeled this triangle a little bit differently in retrospect. So it's C prime is equal to A prime, because A is the hypotenuse now. The hypotenuse needs to be on the right-hand side. So what that means is if I plug in, I have a B is equal to 5, B prime is equal to 4, C is equal to 12, C prime is negative 3, I need to add those two quantities, is equal to, I don't have A or A prime, and I can't have two unknowns. So I need to find A, and that's just using Pythagorean theorem. So again, if I had a triangle, right triangle, where this was 5, this was 12, and this was, we'll just call it A because that's what we're finding, we need to find this length. And it should be 13 because this is a Pythagorean triple, but I'm not quite certain of that. It might be a square root. Let's double check. So it's going to be 5 squared plus 12 squared is equal to A squared. That's 25 plus 144 is equal to A squared. This is 169. Yep, that's 13. A squared, and then square root both sides, and I get plus or minus 13, but can't have a negative. Therefore, A is equal to 13. So I have 13 plugging in here, and there's the A prime that I'm looking for. Remember, I guess I should have said in this equation, how fast is this changing means A prime is what we're looking for from the question. So there's A prime. Let's go ahead and do some math. So this is negative 36 plus 20 is equal to 13 A prime. And that's going to be negative 16 is equal to 13 A prime. And therefore, A prime is equal to negative 16 over 13. So it's decreasing at this rate, and there it is. B, decreasing at that rate, and it's centimeters per minute. They have the right units, and all of them have the right units. All right, that concludes self-check 4.1. Go ahead and ask the substitute for self-check 4.2 to do that in class, and then watch the next video. Reminder that self-check 4.3 is going to be done for homework. All right, thank you for watching.